So in this video, we're going to look at questions 7 through 9. So for question 7, we're told that in the xy plane, we want to find what is the y-intercept of the graph with the equation y equals 2 times quantity x plus 3 times quantity x minus 4. Now, the worst thing you could do here is actually multiply out these binomials. You will get a quadratic equation. This is just going to be a parabola. You could find its y-intercept. However, it's much simpler to do this by just recognizing that the y-intercept of any graph, you cross the y-axis when the x-coordinate is 0. So all that you're really asked to do in question 7 is to plug in x equals 0 into that equation that you were given. So if you notice, I take the original equation, which was y equals 2 times quantity x plus 3 times quantity x minus 4. I plug in 0 for x, I do some simplification, and I find that when x is equal to 0, y equals 2 times 3 times minus 4. That turns out to be 6 times minus 4, which is just minus 24. So what that tells us is that for this equation, when x is 0, y equals minus 24. The value of y when x is 0 is the y-intercept. So the answer here is just A. Let's look at question 8. This is something that we actually didn't go over within the actual worksheets for the TSI prep, but hopefully you've seen before. What you're trying to do here is to factor or write as a product this binomial. And the key thing that you want to know is this binomial, x to the 4th minus 1, is a special type of binomial. It's called a difference of squares. Particularly, the first term, x to the 4th, can be written as x squared, and the second term, 1, can be written as just 1 squared. And anytime you have a difference, which means minus, of squares, a squared minus b squared, you can factor it as the product of two binomials, a plus b times a minus b. So really, what are you going to fill in for a and b in this general formula? Well, it's going to be whatever the square root of these two terms are, x to the 4th and y. So what value do you square to get x to the 4th? That's x squared. What value do you square to get 1? That is just 1. So you can factor x to the 4th minus 1, the difference of squares, as x squared plus 1 times x squared minus 1. Now, what do you notice there in your result? X squared minus 1 is also a difference of squared. X squared is just the quantity x squared, and 1 is just 1 squared again. So we can factor x squared minus 1 as x plus 1 times x minus 1. And don't forget, you still have that factor of x squared plus 1 remaining. So this actually factors into the products of three binomials, x squared plus 1. We got that from doing our first initial difference of squares, and then x plus 1 times x minus 1. That was a result of our second factoring of difference of squares. So the answer there is actually in that problem. Let's get which one we were talking about, problem 8. And that answer is A. It's written in a different order, but remember, binomials or anything that you're multiplying together, you can always switch the order of your multiplication. So let's look at question 9. We have a monomial, 3 times x squared times y to the 3rd, and we're trying to cube it. The key thing you want to remember here is when you cube a product of things, you cube each one individually. So how do we actually go about doing that? 3 times x squared times y cubed. If we cube that, we're going to cube the 3, we're going to cube the x squared, and we're going to cube the y cubed. So if you notice, that's what I've written here. How do I cube 3? That's just 3 times 3 times 3, which is 27. How do I cube x squared? That's going to be, remember, whenever you have an exponential term and you raise it to a power, you multiply the powers together. So that'll just be 2 times 3, which is just 6. When I cubed y cubed, that's going to be an exponential term with a base of y. Multiply the powers, 3 times 3, that's going to give you 9. So from cubing the 3, you got 27. From cubing the x squared, you got x to the 6th. And from cubing the y to the 3rd, you got y to the 9th. And that actually turns out to be the answer of D in this actual problem. Just making sure I circled the right one, and I did. So I will see you all in the next video.